Hello again, it's me. Time for more math. So we're looking at SG4 and we're talking about equations of sinusoidal functions. So the equation looks like that. And we are used to just y is equal to sin x. It's what we normally have. And all the stuff we've talked about is mostly been that. But now we're going to start using letters in front of the x, in the bracket, and at the end. So that's why I call it messing with the standards. And I don't know if that works for you guys. Move around where my little face is. All right, so step number one is being able to literally get the ABCD properly from the equation. Not a big deal. One of the things you can do, I won't do it all the time, but if you're having a bad day, take this and write it oops, right? Oh, hold on. That'll work. Write it right above or right below the equation you're given. And now it's really easy to see, well, my A, there's my B, there's my C, and there's my D. A little note, just take the equation signs with you. So A is 4, B is 3, C is minus 25, and D is 2. We could argue whether that sign is a minus or a positive, but just make it minus and it's fine. So just pull them right off the equation. Okay, do the next one. So we got minus 7. Uh-oh. We need a number for B. So what is the understood number right in front of this x here? What could we put there so it doesn't change our value? Yeah, 1. Right, so we could have 1x in there. Oh, wait a minute. I use colors. No. Sorry, I got a snazzy pen from a student. It makes me happy. Now we've got the plus 10 and minus 20. So let's try the next one. So same story as before. We're missing the value. Whoopsies, missing the value here. You can put a 1 out in front. So A is 1. B is 0.3. Now the problem here is this the C or the D? Well, here's the trick. To have a C, you have to have a bracket. If there's no brackets, then this is the D. So that's 2. So if we look at our original equation up here, okay, maybe we'll go through it right now. If A is missing, see, because it's A times sine something. If I multiply by 1, I'm not changing my value. So this can be a 1. This is B times X, same story. I can put a 1 there. This is understood ones that we just don't write. Well, what about subtracting? If I subtract 1, I'm going to change the value. What can I subtract and not change the value? What do you think? Yay, 0. So if you have so much $10 in your account and you take out nothing, you still have $10 in your account. And the same story for the D. If it's missing, because you're adding that value on at the end, boop, 0. So when A and B are missing, it's 1. When C or D are missing, it's 0. So we'll put a 0 in there. Okay, so back. Yeah, we're good. You know what? I think you should pause the video. I bet you can do it already. Remember, if you get lost, you can always go y is equal to a sine bx minus c plus d. It's like a lot bigger than the equation, so maybe it won't help, but there's my a. Now the b is a number right in front of this x, so that's going to be a 1 because there's nothing there. And remember what I said here. If there's no brackets, there's no c. So we put in a 0 and minus 2. Let's try it again. There's my a. There, I can put in my b. But this time, because there's brackets around the x minus 2, this is going to be minus 2, and there's nothing at the end. D is going to be 0. Okay. That was the point kind of those two questions. Brackets, you got a C. No brackets, it's a D. Another hint, if you're actually having to graph these, right, this was just practice, so it didn't matter if my numbers are going to work out nice or not. C tends to be multiples of, 90 and 30 and 180 and like kind of angly numbers you're used to. D tends to be maybe 1 to 5. And I say that because, you know what, I'm looking at, look at this equation, this one right here. Okay, this tells me, well, I guess I'm getting a little ahead of myself, but this tells me my midline is at minus 20. I am not going to make you do a graph where the middle of it starts at minus 20. That's ridiculous. Anyway, back to the work. Oops, that one's weird. Okay, what's the understood number? And you can have negative a's and 3 and 90 and minus 10. Now, before you answer the next one, look at it and what's weird? You compare this equation to everything else. Every other single equation starts with y equals. So you need to move stuff so it's y equals, everything else is on the other side. So I'm going to go plus 15 and plus 15. So that disappears. So we have just y equals, and now we're good. So there's an understood 1 there, and a 2, and a minus 45. And notice, because it moved from one side to another, sorry, I made a mess, this negative 15 over here has now changed to a positive 15. That's a big deal, right? That's going to change your answers. All right, so sine x couldn't get simpler. Number out front, 1. Number in front of this x, 1. Number in the brackets, well, there are none, so that's a 0. And there's nothing at the end, and that's a 0. And then I think I was trying to fill the page. So you can tell because there's a meme at the bottom. Well, you know what? That's not a sinusoidal function because there's no sine in it. But if you think about it, y is equal to 4. That should be a nice horizontal line crossing the y-axis at 4. So, you know what? It would be 0. Never mind. It seemed really smart when I made these notes yesterday. There we go. Forget that. Okay, reminder. Oops. If A or B is missing, it's understood. What was the deal? Oh, wait, I'm going to write it. Oops. Sorry. Don't know, I won't keep wanting to put 2 today. It's an understood 1 because you're multiplying. So 1 times sine is just sine, or 1 times, sorry, b times x is, try it again. 1 times x is just x. But with C and D, you're doing addition and subtraction. So you're, sorry, I'm trying to think, there's a fancy word for it. But it's the value that doesn't change, that you can add or subtract and doesn't mess up anything, is a 0. Make it parallel, adding or subtracting. Okay, well, it looks like that is the end of that video. Have a spectacular day.